Welcome to the Profitable Python with your host, Ben McNeil. On this episode, you will meet Vladimir Bok. Vladimir is a senior product manager overseeing machine learning infrastructure and research teams at a New York-based startup. He co-authored a book about generative adversarial networks. Vladimir, welcome to the show.
Yeah, thank you for having me. It's a pleasure to be here.
Yes, sir. This is going to be a lot of fun. So before we go anywhere, I need you to help me help me explain to my 90-year-old grandmother what in the heck is a GAN.
So I like to start with just explaining the use case. So GAN is a machine learning technique that allows computers to generate photorealistic data that is synthetic. So it's a way to generate images that are not of real. They are not a real photography, but do look just like a real photograph would. So that's and then and they do, and as the name may suggest, they learn through a adversarial framework where there are two neural networks effectively locked in a cat and mouse game. And as one gets better, the second gets better as well. And that allows one of the networks to generate the photorealistic imagery, while the other one is learning to distinguish the photorealistic imagery that was generated from the first network and identify it as fake as opposed to the real images that are in the training data set. I believe that was slightly convoluted. I may get another shot on it, but broadly speaking, and it's a way to generate photorealistic imagery through a competitive dynamic between two neural networks.
Yeah, it's definitely, so you would consider this an advancement in the technology because up to this point, it was only one side of that coin. Is that kind of?
Yes, definitely. It's paradigm shifting. So historically, when we look at machine learning and deep learning, then it was always about a subclass of it called supervised learning, where there is a data set where you know the answer. And then you have tens of thousands of examples, each with a label, such as a set of images, and there is a dog on the image or there isn't a dog. And you feed these into a machine learning algorithm, and the algorithm learns to identify the patterns in this data and to be able to associate a previously unseen image to the correct label, as in, does it have a dog or it doesn't. So computers have been able to learn extremely complex functions between input data and the correct output label. Other places where computers have shined are game playing. So for instance, in the late 90s, DeepMind defeated world chess master Garry Kasparov in a match recently. The game of Go was conquered by machines. So, and that's another area where they shine because it's a fairly well-defined problem space with a clear objective, and computers can learn through countless simulations where they can determine the correct path. However, when it came to generating, so to summarize, computers have been tremendously good at identifying patterns in existing data and leveraging this insight into tasks like classification, which is determining the correct label for an image or soundtrack or something like that, or regression, which is predicting like a time series number and things like that. But historically, computers have been fairly poor at generating new data. So essentially, you can think of it as doing the process in reverse, taking a label, like a dog, and then generating an image of a dog without, like, essentially, again, like it's like a classification in reverse. And there is multiple technical reasons why this is a very complex task. And it truly wasn't achieved until 2014 when Ian Goodfellow, who was at the time a PhD student at the University of Montreal, and his colleagues have invented generative adversarial networks, which is a completely novel learning paradigm, which pits two neural networks against each other, and that really allowed machines and artificial systems to do the process in reverse and generate from what is often no more than random noise or some input label, and generate a photorealistic image or even a video.
Yeah, my experience with these, it's been they're super hard to train, and then the little data set that I was working on was with fashion designs, and some other people that I was working with this on, they would get like when they were training with shirts and pants and shoes, they would get like shirt shoes and stuff. So
Yeah,
is there like how does that kind of play into the mix? Because maybe it didn't have enough time to learn like, oh, a shirt shoe is not a real thing, or is there another type of learning that it would need to integrate to say like, you know, we have shirts and we have shoes, but shirt shoes are not a thing?
Yeah, so there is a range of challenges due to the complexity of this learning technique, and the GANs are notoriously tricky to train effectively, because the underlying algorithm and the optimization process through which it goes, or the learning process through which it goes, is not guaranteed to converge, because those are extremely complex spaces which have often millions of dimensions, and as humans, we can visualize only three, that have to be optimized to against some objective. And now if you have two of these, and this would be just with a single neural network. Now we have two of these competing against each other and learning from each other's mistake. So it's part, much like all of deep learning, it's part art, part science, where most results don't have mathematical, unlike in classical machine learning, there are no true mathematical guarantees that a certain model will converge or what needs to be done for it to achieve its objective. It's all the like mind-bending findings in deep learning have been determined empirically, where researchers just try something based on intuition and then see if it actually yielded reliably the result. And then it also leads to like very interesting research areas where people make assumption about how a particular model works or what type of internal representations it develops, and then run a test with a trained neural network to see whether it actually is consistent with the hypothesis they had. And a lot of these are about the different semantic representations that these models learn, and there are some fascinating findings both in natural language processing as well as with images and GANs in particular, where in what ends up being completely unsupervised fashion, the neural network is able to learn different concepts that constitute an image. Meaning, if you feed it a data set of human faces, it is able to develop an internal representation for what glasses are, or for what facial hair is, or different hairstyle and things like that. And then there are really interesting manipulations that can be done to generate or compose an image that the researchers would like to be produced. And you may have seen actually in the news recently the different applications that make people look older. So you take a selfie, and then the algorithm immediately turns you into an older or younger version of you. Mm-hmm. And those are almost exclusively based on generative learning, where like the algorithm is unable to see you older or younger. There is no data set to train on. But by learning about, but by being fed a data set of what ends up being tens of thousands of images of human faces at various age stages, it's able to determine the concepts of what constitutes an aging in the context of human faces, enough to actually generate very convincing results to capture the imagination of of broad media and the app users.
There's like three things that are just exploding in my brain right now. I got to ask. One, there's something going on with maybe the implications of where ethics has gone since GANs have come on the scene. I'm curious how you kind of see that changing. And then also I've noticed that computing power is like, my computer was good for like some of these other things, but when I threw GANs into the mix, it was just like my computer couldn't really handle it. So there's implications for the infrastructure with these as well. And then the other thing that just kind of triggered in my brain what you were talking about here is there's an art and a science to these. And I know that you've written a paper on Medium about kind of like the art of like how generative networks are working with art, or like the implications of human creativity. So do you think AI could actually make better AI, or is that already? I don't mean to bombard you. That was just like all these things. I was like, I gotta ask this stuff.
I think your question started with like there are three things to touch on, and I can already see like a dozen others that are there to be unpacked in your answer. So first one, I will start with the latest, the thing that you mentioned at the very end, which is AI creating other AI. That if you look historically at technology, that has always been the part of the debate. When first machinery has been introduced in factories, and this is hundreds of years ago, the question was like, what if there are machines created other machines? And that was a really scary thought to humans, because it used to be that humans created the machines and put them in the factory, and that created whatever those machines were meant to do. But now we live in a world where that's common sense, right? We have factories creating that have no other purpose than to create other machines for other factories. And now we are getting to a similar stage with artificial intelligence, where GANs can be seen as the first step towards it, where we have machines training other machines. That has always technically have been the case in game playing, where you can have just two game playing, like just playing bots, and they can just play against one another. So there seems to be a component of AI helping to train other AI, and I believe we will see more of that, especially with we already see applications of it with self-driving cars and that are trained in simulated environments and other use cases. So that's towards the last part of the question. To continue on. Artificial creativity, you noted that I have written about it myself. I think it's a really interesting area, both practically and philosophically, because when we look at and this is something that I was, it's been keeping me up late at night, is that historically humans have always sought to distinguish ourselves as unique or superior to the rest of the living forms. And this goes all the way back to millennia ago, where religions have started. And no matter at whichever we look, as humans have always been seen as superior to other species. So in Bible, we are divinely ordained to have dominion of our species. Even in Buddhism, it is no other life form can attain enlightenment than a human. So there is always a sense of superiority of us as species. And then that notion began to crumble with science and discovery of the genome and other like evolution, origin of species and all that effectively put humans on the same evolutionary tree. But then science helped us also to define ourselves as distinct. Like we have opposable thumb, we are able to use tools, we are able to communicate with each other and organize in ways that other species just cannot match. And if you look around ourselves and civilization and all that humans have been able to accomplish, even the fact that we can have this conversation digital and record this podcast, it's something that is magic-like. And again, no other species come even close. But now with the but it was always, to an extent, our intelligence that distinguished us, right? We are not stronger than other species. In any battle, we are essentially hopeless. But we have been always able to outsmart them, and now we are effectively, thanks to our tools and our ability to organize and think intelligently, we are on top of the food chain in almost any habitat. But with the advent of artificial systems that are capable of emulating our intelligence, that notion that that intelligence is what distinguishes us from other forms of life, even digital ones, has begun to crumble, in that sense that it doesn't seem to be something that we can continuously rely on. Right? We humans have been beaten in now any game ranging from chess to Jeopardy. And although all AI systems, even the most advanced ones, are effectively single-trick ponies, right? Like the AlphaGo that beat the best Go player, it can only play Go. You can't have a conversation with it, like you can have it with a fellow human and things like that. But it seems almost inevitable, and again, this is only speculation because there is a wide debate about whether general AI will be achieved. But it seems that the technology is moving in the direction where it's conceivable that there's going to be an artificial system capable of emulating what we would see as true human general intelligence or even consciousness and rationality. And then the question becomes, is art going to be what will be our distinguishing feature? Because art is something that is hard to imagine a being other than human, even if it's an intelligent one, to be able to engage in or want to engage in. And my point my viewpoint on this is that if we allow ourselves to believe that artificial general intelligence, meaning independent artificial intelligence agents that are indistinguishable from humans in our thought processes, would be able to match us on all cognitive tasks, then it seems naive to believe that creativity and artistic expression would be somehow magically out of the domain of these extremely complex systems, because and that's a broad point. And I end on that. And then it's interesting to think about, because then we can loop it all the way back and look at creation, which would be, if the dystopian scenarios prove correct, and AI agents not only match our intelligence but also choose to replace us or decide that humans or biological forms have been superseded, and we as species end up being exterminated by our creation, then it will be really ironical, because all these AI agents wouldn't be suffering from the type of existential soul searching that plagued us humans for millennia, because there would be no question about what makes them distinct, because they have been created. So in the end, as humans, we may not be divine in our origin, but we might be divine in our undoing.
It's really just a mental explosion. We could just end the podcast right there, and you could chew on that for the rest of your life.
Yeah, it's something that's been on my mind for a long time. Actually, that's how the way that I actually got to GANs was through a creative application. So you may have seen, because even on your cell phone, the different apps that allow you to put a filter on a photograph that turns the photograph to look as a Van Gogh painting or a painting from your artist of choice. It essentially renders it in a very believable way to look in a specific stylistic treatment. So again, like Van Gogh painting Starry Night was a very, very popular one, popular filter to use. And and this was back when I was working at Microsoft. My colleagues and I did a project where we tried to do a similar artistic style transfer in music. So you can imagine taking a track from Justin Bieber and applying the style of Beatles to it, or and other arbitrary set of musicians,
Mm-hmm.
and see whether you can play one track in the style of another. And we know that it is possible because, much like in art, you can imagine a human artist rendering any photograph in the style of a given painter. We know in music, there are pop music tracks that are played by an orchestra. And it's clearly identifiable, although it's a completely different set of instruments and completely different rendering, we can still identify it as the same melody easily and be able to identify what pop music track is being played, although it's not played with electronic instruments, it's played with violins, trumpets, and drums, and other things.
Did you guys go full circle with that project, or was it just kind of like an idea?
Yeah, so we had some, so it was like we had limited success, enough actually, to pique my interest and continue working with GANs for years to come, effectively. And that is one of the key influences actually behind the opportunity to write a book about GANs with my co-author Jacob.
Mm-hmm. Cool. Yeah, that's awesome. Yeah, I just kind of went off there. I had like a line of questioning, and I just got curious and went off. So
yeah, this is a topic that lends itself well to tangents.
Yeah, I can imagine.
Yeah.
Oh man. Yeah, so I'm just looking through here. What applications do you see semi-supervised learning having the largest impact going forward?
Sounds great. So let's first define semi-supervised learning.
Okay.
So we have there are three main classes that we can classify machine learning and deep learning approaches into. First one is supervised learning, which we covered at the beginning of our conversation, mm-hmm. where you have a large data set and each example has a label. So all the algorithm needs to do is to learn a mapping from the input data into the correct label. And do it so in a way that generalizes well to unseen examples, meaning if you provided an image or a data point that wasn't seen in the training data, it's still going to be able to assign the correct label or predict the correct numeric value or what have you. In the other of the extreme is unsupervised learning, which is there are no labels, you have a large data set, so you help machines to learn on them by themselves the useful patterns in the data, which then can be leveraged for a range of purposes. Good example there would be clustering. You may not know if there are any commonalities within your data, but you can run a clustering algorithm, and the computer will tell you about like the different clusters that are represented in what may be extremely complex data sets. The vast majority of applications in industry are in the area of supervised learning. It's any object recognition, image recognition, even text to speech and things like that. Those tend to be largely supervised learning algorithms. But vast majority of data sets are unlabeled, which has really been limiting the usefulness of the applications which can be used and derived. So semi-supervised learning comes in a bit to the rescue, where it's a combination of the two. You have a data set which is all of the same nature, meaning it can be all images of animals, for instance, and then you have only a small subset of the data set where labels are provided or available. And then you learn, and then you train a semi-supervised learning algorithm, which has some trick, that uses the entire data set to learn useful patterns, and then the subset with labels to then apply those learned representations into the correct labels. And what ends up happening is that you can achieve similar levels of predictive performance or accuracy or other metric that you care about with semi-supervised learning with only a small subset of examples that you would be able to achieve with a fully supervised approach. But what we are talking here is, let's say, only 1% of what you would of labeled examples compared to what you would need with a traditional supervised learning approach. So it's effectively a way to help machines to generalize extremely well from very limited data sets. And what's interesting about semi-supervised learning and why it's been very fascinating to me is that it seems to be in machine learning the closest analog to how humans learn. Because when you look at school children, there is one textbook with letters and numerals. And then children, once they learn these symbols and read these symbols and what they mean, they can then read those letters in all kinds of different fonts, lighting conditions, angles, and situations, which traditional supervised learning approaches wouldn't be able to. Traditional supervised learning approach, you teach it a set of handwritten numerals or like numerals, and it needs to be provided examples that are very similar like in the same sort of domain that they have been used to or seen in training data. For humans, that's not a problem because when children are able to read from one textbook and then read any font, or again, an angle and the lighting conditions, things that normally would trip a machine learning algorithm. And supervised learning approaches are helping to for machines to generalize from a similarly small data sets into all different types of contexts.
How is that? Just my intuition tells me like that can be kind of dangerous to extrapolate something from like a small set of data. But then what you're talking about with like a child learns from like these basic materials and they can create everything and beyond. So is it does it boil down to like computing power or special types of algorithms, or what is it going to take to make it work, I guess?
Yeah, it's a great question. So what you touched on has been the bane of machine learning since inception, which is overfitting, which is effectively training an algorithm. And you see amazing performance on the training data, but what actually ends up happening is that the algorithm memorizes the training data set. And the moment you show it an example that wasn't represented in the training data, it completely flops. It just gives you a useless prediction. And there are some really hilarious real-world stories where that people fell prey to this to this issue. So with supervised machine learning or semi-supervised machine learning, it's largely been a way to marry the training like semi-unsupervised learning approaches with supervised, so that machines can actually generalize from the small subset of data. And the way that this is done, it's not that you are training on just on the small subset of the labeled examples. You also have a huge multitude of examples of the same nature. So it's again like images of animals, an example that we use, that are unlabeled, but are still something, but still do contain a lot of extremely useful information. And GANs in particular have been very effective as a way to help enhance the semi-supervised learning performance. And we can, and if you want, we can actually walk through the details of how that would be set up and how GANs and generative learning is actually extremely useful when it comes to semi-supervised learning.
Sure.
Yeah, so let me backtrack to the beginning where I botched the explanation of GANs, and let's start from the get-go. So GANs are composed of two neural networks. One's called the generator, and the second one is called the discriminator. And the GAN setup also includes a training data set. The training data set is the type of images you want to emulate. So for instance, if you want the GAN to start generating photorealistic synthetic images of human faces, then you need a data set of human faces and large ones. The generator's goal is to turn what is often no more than just random noise into realistic examples that are indistinguishable from the members of the training data. The discriminator wants to learn the difference between real examples and fake examples. To do that, the discriminator is given either an example coming from the training data for which it learns to assign the label true, or this is a real example, or the probability rather that this is likely to be true. And for the examples coming from the generator, the discriminator learns to assign the label false, as in, or low probability that this is a real example. The generator's goal is to therefore fool the discriminator into believing that the fake examples it produces are actually coming from the real examples in the training data set. So you can see that there is a tension between the networks where the goal of the discriminator is for the fake examples to have low probability of being real, while the generator wants the discriminator to assign high probability of being real to the fake examples it produces. And there is a ton of real-world analogies that actually makes this concept more relatable, such as the one that is commonly used, including by the inventor of the technique Ian Goodfellow, is forging money, where you have some criminal who's trying to forge bills that look indistinguishable from real ones, but then you have also police or detectives who are seeking to tell apart what are counterfeit currency from the real thing. And then as one gets better, the second one needs to get better as well. So the better the fake bills get, the better technology the detective will need to be able to detect them. And then it's a continuous cat and mouse game where both players that are locked in this adversarial dynamic get better. And that actually is encoded. It's pretty much like encompassed in the term that we use, the generative adversarial network. So adversarial networks we just covered is effectively describing the dynamic, and generative is just the purpose of the network, which is to learn to generate realistic data. So to apply this, and in order for the generator to learn to turn what is effectively just a vector of random numbers into photorealistic images, it needs to learn a very complex understanding of what the training data set looks like, and be able to map random noise into a photorealistic image through its internal layers and internal representations. And the discriminator needs to develop a very complex understanding of what constitutes those images so that it's able to effectively tell between real and fake. And to apply this in a semi-supervised setting, we extend this GAN paradigm a little bit by adding labels. So we have a small subset in the training data of examples with labels. And each time the discriminator gets one of those labeled examples, it needs to not only correctly identify it's real, but also assign the correct label. So if it's we have three different cases. First case is that the discriminator gets a fake image. For this fake image, the discriminator wants to tell it's fake. The generator wants the discriminator to tell it's real. So the fake images can get better. But from the discriminator standpoint, it wants to classify fake as fake. For the real images without labels, all it can do is to just tell it's real. And it's optimized to tell the real examples apart from the fake ones. Then there is the third case that we discussed, which is the real examples with labels, where the discriminator not only wants to correctly identify this as a real example, but also assign or classify it into the correct label. So if we had like the simple example of handwritten numerals, it would need to be able to tell, is it the number 9 or the number 8? In addition to being able to correctly identify that this is a real human handwritten numeral. And what's fascinating is that in order to be able to learn the real from fake, even without any labels involved, the discriminator learns very useful internal representations of the complex space that constitutes the real images, which intuitively gives it superpowers when it comes to assigning the labels, because it already has an internalized structure of what constitutes the training data. So when an example comes in with a label, it's not really overfitting, because it's fairly it's able to see what that label means within that complex internal representation. It was able to learn in this effectively unsupervised or self-supervised way. And this is where, and this I think is a really great application of GANs, like a very practical area where we can clearly see that you can have a large data set with only a small subset of examples with labels, and then be able to turn the discriminator into not only an effective system telling what's real and fake, or what's coming from the generator and what's coming from training data, but also leverage those complex internal understandings of the training data into being able to assign the correct label. And in academia, people have been able to, on benchmark data sets, use this technique to achieve similar accuracy with this approach to fully supervised approaches with only 1% of the labeled examples. Which is, and what we're talking about is, yeah, so instead of, let's say, 10 of thousands of examples, you would need only 1,000. You would need only 100, which is
it's amazing. It opens up like a whole, like so many places where maybe you couldn't have done supervised learning. Nothing's off the table now. Is that kind of what I'm hearing?
Yeah, there is still room for these approaches to continue to improve, but effectively, that would be the case. The trick here is that the other examples that are in the training data, they still need to be coming from what researchers say is the same domain, but intuitively it just means it's the same set of examples. Mm-hmm. So it would be able to learn effectively. It was just like a set of random images. It still needs to be images that you eventually want the algorithm to learn to identify properly. So if it says images of handwritten digits, which is a simple example to use for illustration, mm-hmm. all of the examples in the training data sets, labeled or unlabeled, would need to be of handwritten numerals. If there was an image that isn't part of the domain, such as an image of a human face or an image of an animal, then that wouldn't be providing any useful representation in that domain space.
So I guess that I mean that's intuitive what you're saying, but it might also kind of bleed into like the art side of kind of building or staging the right training data depending on the outcome that you're looking for. That's where some creativity is involved, or not so much.
Somewhat, yes. It depends a lot on the use case.
Okay.
So in the basic GAN paradigm, when we want the generator to learn photorealistic images, then by choosing the training data set, we are effectively choosing what the generator will learn to produce. So if we have a data set of human faces, that's what the generator would learn. Or if we have paintings from Leonardo da Vinci, then the generator would learn to produce paintings that resemble those of Da Vinci.
Mm. Is it wrong to say that you're kind of choosing a bias when you are staging that training data? You're kind of introducing like naturally a bias, I guess, with the training data?
Yeah, it's a great question. So machine learning algorithms are often on as good, or effectively all cases are on as good as the examples that you train them on.
Mm-hmm.
And that has been an issue now that machine learning has more and more applications in even the like the justice system, where algorithms may be imagined to be used to determine the the likelihood of somebody to reoffend, for example, or in medical applications, you may learn to see who should be admitted to a hospital or not. Or in workplaces, you may have an algorithm that determines the likelihood of somebody to succeed or be promoted. And those are extremely tricky use cases and extremely dangerous from the ethical standpoint, because the data sets include the biases that we have in our world, and the models will just learn to amplify those biases. So the selection of the training data and being aware of not only the known biases, but also the unknown unknowns, or be cognizant that there might be a lot of unknown unknowns or biases that we haven't foreseen, is extremely important. And it actually limits, for good reasons, the usefulness of current deep learning in many applications, because these models tend to be often very performant, but also feel a lot like black box, even to the researchers that are that are leading the advances in this field. And without being able to interpret how a model has arrived on the decision, it's dangerous to deploy it in situations where human lives or well-being is at stake. So, and then GANs, of course, do suffer from the same type of shortcoming, where, if you have a data set of brown dogs, the GAN wouldn't learn that a dog can also be white or black or have different color. They'll just learn from the data that was provided. And there are also interesting failure cases where GANs just don't end up being able to develop complex enough representation. So there is a complex version of a GAN called CycleGAN, which learns to turn one image from one domain into an image of another domain. So a simple example would be having a black and white image and turning it into a colored image. But there are also more fascinating use cases, like taking a nighttime scene and turning into a daytime scene of the exact same setting. Then there are also examples where you can take an image of a horse and, in this very unsupervised way, turn it into an image of a zebra, where the horse will essentially get like stripes assigned to it. But what's interesting is that the data set didn't have that many horse riders. So when it's a horse with a rider, then it's not only the horse getting the zebra stripes, it's also the rider, which of course is an invalid output, but it's largely a function of the data set, which just wasn't given enough examples of horseback riders, and there are no horseback riders on a zebra. So it wasn't able to actually develop an internal representation of these complex relationships. And this might be only one example of many, but it is the story of caution that as exciting as the results that deep learning is providing, a lot of the practical applications are currently limited because of the very valid ethical concerns with deploying these systems in production and real-world scenarios.
Yeah. One other thing that comes to mind, maybe this is just my ignorance speaking here, but I'm curious, why are GANs not kind of talked about in time series data, like for example, like stock market prices, or that's really like why couldn't you use a GAN for predicting prices, or kind of like reverse engineering price action?
Interesting. So there is a lot of other deep learning algorithms like recurrent neural networks that are well suited to predicting time series. GANs are, it's so GANs are very good, at least in the base version, of emulating a training data set. With stock pricing or sequential data, that would require fairly like complex modifications to the underlying system. So it's so there have been, if that not sure if that if it makes sense, but essentially, like let's go back to the GAN paradigm. So we have the two neural networks, and there is an output, and then we are looking whether the output is real or false. In time series data, it's what is an incorrect way for a graph to go, right? Like stock price can go up and go, or can go down, and you often actually have the base truth. You actually know historically whether the stock price went up or down. So other machine or other deep learning approaches that are learning from sequences to predict the next stage in the sequence are just better suited for this particular use case. And there are examples like that.
Okay, so it's almost
And
like
and
say that again.
Yeah, and there are countless, and it's like a very like a predicting time series because of its immense practical applications. Everything from cost forecasting to in stock trading, price forecasting has been it's a very active area of research, and GANs, and it's always the right tool for the job. And GANs, I would say GANs have been tried in every different domain and every different use case, but generally speaking, just this isn't their forte, because this just would be the wrong tool for the job. Although I would bet that there is a paper out there that actually uses GAN to forecast some prices, because GANs are one of the number of papers published on the topic of GANs has been growing exponentially since their inception. So again, it must be not only one paper out there that actually addressing the question, but probably dozens. I just it's not an area that I've explored, and intuitively, it just doesn't also seem like a place where GANs are set up for success or appear like the right tool for the job.
Fair enough. What there was something actually you said at the end, have a strong opinion until proven otherwise, or there was something along. What was that saying again? Have a strong opinion.
I mean, strong. So it's a motto that I like to. It's like, or a type of mindset that I like to approach any problem, both professionally and personally, and that is strong opinions weakly held. As in, when I form an opinion or a stance on an issue, it's usually well reasoned or based on some sort of evidence, but I'm always open to hearing other viewpoints and changing my mind in light of different data or a point of view that I haven't considered. So again, strong opinions weakly held. And this would be actually a perfect example in which I can think of dozens of reasons why GANs would be ill-suited to this area, but again, people have been extremely clever in finding use cases for GANs and making the necessary modifications that, and I'm always happy to be proven wrong.
No, I love that attitude. It's probably suited you very well, I guess. That's like it's just been a great way to approach life, is what it sounds like.
Yeah, no, totally.
Yeah, thanks for sharing that. That was really cool. I actually had some because you lead a team at your current employment, and I was kind of curious, what kind of character traits do you look for on the teams that you manage, or like what type of character traits seem to um, do better, I guess.
So it's a great question. I think it's always a combination of things. So in um, the type of industry that I operate in, which is data science and machine learning, it's necessary to have some technical and some base technical knowledge, but um, often it's hard work and the correct attitude beats intelligence or raw intelligence any day. So the type of traits that we find in most successful candidates and people who end up, shining at the company and making a real difference are people who are open-minded and approaching problems in a very open-minded way, and also not able to wrestle it to the ground, so to speak, um, um, and yeah, that's and then as in any team environment, and this is a saying I also or a metaphor that I like, is that it's about people who care more about, like, if you are on like a sports team, you need to care more about the logo at the front, which is your team and the team that you represent, than the name at the back, which is usually your name. So it's also about just finding the team players that care more about the broad team success and what makes everybody better off, as opposed to just their own individual advancement, even if it's at the cost of the team.
Yeah, that's excellent. Thank you for sharing that.
Yeah, sure. But it's interesting because I did start off that, even though I work in like a very technical field and probably as academic as it gets, most of the traits that do contribute to success are soft skills ultimately, which is fascinating. Which, is I used to be like extremely studious as when I was little and very much close to myself. But it was a lesson I had to learn the hard way, that I can't just close myself off. And more with experience, I learned more and more that it's not only about it's hard work, but also about attitude, teamwork, and other aspects.
Yeah, thanks for sharing that. I think it's a great reminder. Like I'm certainly enjoying the reminders. So thank you.
Yeah.
What is a good framework to operate in when prioritizing learning resources? Because I know you said in the pre-interview there's just an abundance of learning resources, which can be a problem if you don't have like a framework, I guess, to like filter. So can you kind of share maybe your filtering framework for learning resources?
Can we narrow it, the question narrow it down a little bit to like
Sure.
be learning about a specific technique?
Yeah, definitely. When it comes to like these technical skills, I think a lot of the people in my audience, they're more tending towards data science with Python. So is that a good enough area to kind of zone into, or do we need to get deeper?
Yeah, no, it's a great start. So
Okay.
one thing, this is actually something I did learn a bit of the hard way, is, and this, so the good way to, and this is not a promotion, but good way to learn about topics is actually to pick up a book, because there was somebody who spent an inordinate amount of time thinking about structuring a topic into some cohesive narrative. And even if it is just to read the table of contents or the way that the topics are organized, it's actually a great way to get the lay of the land, especially in the explore area, to know effectively what to Google. Because nowadays, all the information that is out there is very easily accessible, and almost nobody with an access to a working internet connection has excuse not to learn anything that they wish, unless it is, especially when it comes to the programming techniques or modeling. But the issue is often not knowing what term to look up. So like no understanding, like learning the nomenclature of any given field, and what are the most important terms to be aware of and understand, and building a solid mental model of the key concepts, and building an intuition behind like what might be at first like a very intimidating area, I think is key. And often a good way to start is again with a book, because in order to be written, somebody actually had to go through this painstaking process first. And although, you know, if you have 10 different people, they will come up with 10 different categorizations. It's often a good way to start, and all the better if the book was published by an expert, which or a known expert, and ton of recommendations here for deep learning. And then it also depends on how technical people want to get. But if somebody is very technical, then Ian Goodfellow, the inventor of GANs, has published a textbook on deep learning, which is again, this is probably more for mathematical and academically inclined people. But then there is a ton of practical hands-on publications from, you know, a range of publishers. And again, I will keep the won't add any promotional content, but
no,
again,
I mean that's definitely part of the purpose of this podcast, is to shed light on your brand, and you're the creator. This is probably the newest GAN, one of the newest GAN books on the market, if not the newest GAN book that you've written with Jacob.
It's also, yeah, it's often GANs actually are often just reduced to a single chapter in many books, including the textbook written by the inventor of the technique. And ours is one of the first, if not the first, hands-on guides to GANs more broadly from the ground up, that is dedicated to solely to GANs. So we are able to dive into different examples and use cases and applications, and it's very, and much like all of the publications from our publisher, it's meant for practitioners, and it's very hands-on. It's light on theory, except for only the essential one, and it's mostly just walking through examples, diagrams, and developing the intuition for why things are how they are.
So when they crack this thing open, they can expect a lot of hands-on, practical code, and
Yeah.
Is that okay?
Yeah,
and I know that's. Oh, go ahead.
Yeah, there are several GAN techniques implemented from the ground up. It's on small toy examples, but it's very good for the instruction of just learning the concepts and the different modifications that can be done on the core GAN model to apply to different use cases. An example that comes to mind is that the core GAN is able to generate photorealistic imagery, but it's a random image. So if you have an image of human faces, it can be any human face that comes out, because it's random data being turned into a very black box way into a photorealistic image. But you have no control whether it's a man or a woman or an old person or somebody with long hair, short hair, what have you. But there are modifications that can be done to GANs where you introduce additional information and you condition the training on this additional information, and then you can ask the generator to produce an example to your liking. So in the example of human faces, you can tell it that you want to produce an elderly woman or a man with long hair, or any other example that might come to mind with the labels that you condition the training on. And yeah, so that's just like one example that we cover, but it's truly, it starts from the basic GAN and the intuition behind it, and then builds towards the the more advanced applications with the practical applications of it in mind.
And the other question that I was going to ask you was, what type of arena, I guess, would you get a job, or kind of like if you had a mission to get a job in a certain space or to be an entrepreneur in a certain space, why would GANs be more on your radar? Like, is there a certain niche or industry? Do you have any insight on that?
Yeah, so GANs have actually seen for like very novel machine deep learning techniques. They have seen in industry use cases fairly quickly, and they have shined particularly well with imagery. So it's any area where images need to be manipulated. So, for instance, in many image pieces of image processing software, where you are either making somebody older, younger, or even changing the lighting of an image, then that's where GANs are actually used in these consumer use cases. So a lot of the actually, if on your phone there is any app that modifies an image or like enhances features in like a selfie or things like that, it's probably based on GANs in one way or another, or one of those use cases is. So I would say it really depends on what people are interested in. Other places where GANs have a lot of experimental use cases currently is medicine, where I imagine it's actually extremely costly to come about a data set, right? Because you need to, there are both privacy concerns and practical limitations to be able to actually come by a data set of medical conditions. But it's also extremely important to be able to classify these data sets or make determinations based on data sets, or even teach medical students based on relatable examples. And GANs have been actually used to enhance a lot of these like data sets in area where data is scarce or expensive to get. And then there are also countless applications of GANs in creative endeavors such as fashion. So Amazon actually in their labs is known to use, or has been reported to use, GANs to be able to predict like fashion trends, or even be able to generate new fashion items that would be matching either individual's liking or a given trend. Because what's interesting in fashion, particular, is that change tastes all the time. It depends on the season, depends on what's being promoted. So historical data, even though there is a large data set, they might not mean much, right? Like something may have been in fashion last season or even last month, but it's no longer sellable today. So your data set, coming back to the concept that we discussed previously, is going to be biased based on the historical trends, which may not actually have any, in the case of fashion, may not have any predictive value for what the future consumer behavior would be. And GANs are actually able to learn a lot of the more complex patterns there. Other area where I would expect GANs to be used is in animation and game design, where usually it's very expensive for human animators to generate new characters, or in a game to generate new characters. With GANs, you can effectively imagine that you can create an endless variety of both environments and characters and creatures within it that match certain criteria, like a distinct style of, let's say, a Pixar movie, or a distinct style of a classic Disney movie, but wouldn't have been explicitly created by a human animator. And in game playing, you can imagine like a GTA-like game where the world is truly endless, in a way, in a very believable way. So I think GANs as a way to either enhance existing data sets as in medicine or modify in a believable way existing imagery like the image editing that we covered, or help enhance human creativity with generating examples that fit into a certain domain in a very believable way. I think those would be the three top areas, but likely there's countless others.
Sure. Yeah. Thanks for sharing that. What was the like biggest takeaway, I guess, from writing that book? Because I know you said it was kind of like a learning adventure while you were writing it.
Yeah,
What
definitely.
was like the big takeaway?
So the big takeaway, there's multiple. For me personally, it was that always think about book writing as a process of imparting knowledge on someone, right? It's about sharing what you know about the topic and then hopefully helping others learn more effectively about it, those who are interested in, which is a very humbling process in itself. But what has been most eye-opening about writing the book is that it itself is as much a learning experience as it is an opportunity to teach. So during the process, I learned a lot more about the topic than I knew before I started the book, because I have to research it through in depth and make sure that the information present is accurate and it is presented in a way that is understandable, even to your grandmother, as you mentioned.
Yeah.
And other thing is that thanks to our publisher, we actually were able to share unfinished manuscripts directly with our readers who are interested and who were able to provide us feedback as we are writing the book. And that helped me improve both as a writer and as way to effectively communicate information, but also actually brought my attention to areas of this topic that I wouldn't have considered myself, and actually had to be able to zero down on and learn to explain. So again, it's been I think I learned. This might sound strange, but I think I learned probably as much, if not more, as any of our readers during the process. Although, as much as I would like to hope that the book will also be a great learning resource for anybody who wants to learn about this topic.
Yeah, that's awesome. And we have some. The publisher provided a discount code for the listeners here, and then we have a few codes that I'll be using to give away to the folks. So certainly, the name of the book is it's GANs, and then
GANs, and the subtitle is Deep Learning with Generative Adversarial Networks. And what I think was going to be of particular relevance to your listeners is that all the examples in the book are in Python. And in particular, we used Keras, which is the deep learning library for Python that makes building neural networks almost as easy as playing with Lego bricks. So that's been great. And more broadly for deep learning, actually, and the discount code will apply to that as well. The book Deep Learning with Python, written by Francois Chollet, who is the inventor of Keras, is also in the portfolio of our publishers. So if somebody is looking for deep learning introduction more broadly, rather than GANs in particular, then that would be a really great resource. But for GANs, I would like to hope that our book is one of the more useful ones.
Yeah, that's awesome. I'm so happy that you had time to come on the show and do this demonstration of your knowledge and kind of imparting on this on the audience. I just had a couple of wind down questions. I know we're way over time here, so if I had to pick like two of these, one is, what is the best piece of advice that you have ever received?
Oh wow, that's a tough one. I think the best piece of advice is received from as I was starting in the university, it was don't compete but connect, which I think extremely well summarizes the notion that it's always better to cooperate with others and not compete with one another. And that's been actually very eye-opening, especially in classes where everybody was on a curve, meaning the grades were determined relative to each other. So there was actually through like zero-sum game amongst the students. And yet those who have been most successful were those who learned that the lesson that I just mentioned, which is it's always better to focus on teamwork and collaborate with everyone than to try to close to oneself and compete in isolation.
That's awesome. Thanks for sharing that. What is the best non-technical book that you've ever read?
Sapiens.
Sapiens.
Yeah. By Harari. It's a fairly short book, about 300 pages, and it's extremely insightful about just that it discusses the arc of human civilization from prehistory to the modern age in very thoughtful and synthesizing manner. And although it's a very short book, it's very well reasoned and doesn't feel rushed. And it's one of those books that does make you look at the world slightly differently. And it's been so for that reason, it would definitely be on the top of my list of recommendations.
Cool. And what do you hope someone takes away from this interview?
It's a great question. I hope it's, if nothing else, I would like people to have a basic understanding of how GANs function. I felt miserable at the beginning. I hope that towards the end I improved my explanation. And I do hope that at least some of the way that GANs work stuck with people, and hopefully it sparked a curiosity to learn a bit more about the topic, either through our book or through other resources that are out there. It's truly a fascinating paradigm that is both academically but also practically extremely fascinating, and I would encourage people to learn more about it.
Well, I'll just say this: you did a better job than I could have done. So don't. It's a tricky subject, and I'm so happy. I mean, you're definitely put in the effort to write the book, and I'm happy to have you on the show. We can showcase this knowledge. Other than that, what is kind of the call to action? Like, where can people find you? Is the best place to go get this is at Manning? What is your main call to action here?
Yeah, so Manning is where the discounts will also apply. So it's probably the best way to get the book. In terms of call to action, I like to stay engaged with the community through my Medium blog. So we actually covered some of the ideas that I discussed in depth in my blog post, and I seek to continue contributing there. And it's been just a great way to engage with the broad community. So the book itself is somewhat static. We have a forum where people can ask questions, and Jacob and I respond to any questions that people ask in the forum. But when it comes to like continuous engagement with the community, then I'm always very thankful for anybody who reads and provides feedback on my pieces on the blog. And that's currently in Medium, and through both HackerNoon and Towards Data Science and other Medium-based publications is where I contribute. Just visually very nice, pleasant place to run a blog.
Excellent. Yeah, I certainly have more lines of question here, but we'll just table it for now. I know it's getting late where you're at, but yeah, you saw how the can of worms just kind of like, if you leave me at the front of the ship, I'll just ask questions all night. So thanks again. This has been a blast. And was there anything else we left off the table, or you feel good about everything we've discussed here?
Yeah, I think there's one more thing that I would like to mention.
Sure.
I'm donating all of my proceeds to the nonprofit organization Girls Who Code. So, although some of the content here might have felt like congratulatory and promotional, I have, again, all of my proceeds go towards a good cause, and that it's been one of the more rewarding aspects of actually writing these publications as well.
Excellent. So it's going to Girls Who Code, right?
Yeah, it's a New York-based nonprofit that helps more young girls to get excited about opportunities in technology and pursue both studies in STEM fields and also careers in those fields, and thereby helping to close the gender gap that currently exists in technology.
That's really cool. I'm glad that you were able to add that in here. I don't know how I would have unveiled that if you didn't share it. So thank you for sharing. I think that's super exciting, and we'll certainly include that when promoting the book, if you're okay with that.
Yeah, I would. I would find that helpful. Yeah, it'll be great.
Awesome. Well, Vladimir, thank you so much, and everyone else, I'll talk to you soon. Bye.
Yeah, it's been a pleasure. Thank you for having me.
You're welcome.